8.3, graphing f of x equals ax squared plus bx plus c. So we've dealt with the a and the c in the previous two sections in 8.1 and 8.2, but we haven't seen what happens yet when we have a coefficient in front of the b. Okay, so like we do in both of these problems. Okay, all right. So the axis of symmetry, we've talked about that a little bit. It's a vertical line that splits the parabola in half. It's right in the middle of the parabola. There is a formula for it, and it looks like this: x equals negative b over 2a. Okay, it's always going to be an x equals line because that would give you a vertical line, right? So this particular one looks like it would be x equals 1 because all the points on this line have an x coordinate of 1. Okay. All right, and then the vertex, we already know that that's the point at the very bottom of a parabola that opens up, or it's the point at the very top of a parabola that opens down. Okay. But we're going to talk about how to find the coordinates of the vertex. And it's related to the axis of symmetry. So you notice here the vertex is on the axis of symmetry. That's going to happen with every parabola. So, you know, I know what, just looking at this, I can see this is the point 1, negative 3. But the x value is 1 because it's on the axis of symmetry. So for any parabola, you can find the x coordinate of the vertex by using the axis of symmetry. Okay? So I'm going to write axis of symmetry. That's going to be your x coordinate. And then your y coordinate, you can find that using the x coordinate. So we'll get to that later on. Okay. We'll get to it right now. So let's look at this. First off, this is for equations that are in this format where you have x squared plus the x term plus something else, right? And you might have coefficients in front of these two. So here a is going to be 1 because there's nothing in front of the x squared, right? B is going to be 6, and c is 5. Okay, so it's important to recognize those things first. So to find the axis of symmetry, I'm going to use the formula. It's going to be negative b over 2a. So what I'm going to do is plug in 6 up there. So it's the opposite of 6. And then 2 times a on bottom, and a is 1 here. Okay, and then I'll simplify this. So this is going to give me negative 6 over 2, and negative 6 divided by 2 is negative 3. Now, a lot of times when I ask for an axis of symmetry on a test, people say negative 3. But negative 3 is just a number. It has to be x equals something to make it a vertical line. So I really want to say that x equals negative 3. The x equals is important because that makes it a vertical line. Okay? Now, if I had graphed my axis of symmetry, x equals negative 3 would look something like that. Well, I know the vertex is going to be somewhere on the axis of symmetry. So when I'm figuring out what the vertex is, I know the vertex is going to be negative 3 something. So I just have to figure out the y coordinate. And the way I'm going to do that is I'm going to plug in, I'm just going to use y here instead of f of x, okay? I'm going to plug in negative 3 for the x in both positions into the equation. Okay? So now I'm figuring out in this equation, when x equals negative 3, I'm going to figure out what y equals. Okay? And then I'm going to use PEMDAS from here. So let's see. I'm going to do the exponent first. Negative 3 squared is positive 9. Then I'll do this multiplication. 6 times negative 3 is negative 18. Okay, and then I'll do the subtraction, which would give me negative 9. And then finally the addition, negative 9 plus 5 would be negative 4. So that's the y coordinate. So when x equals negative 3, that means y is going to equal negative 4. And there is my vertex. Okay. All right, let's find the y-intercept. Looking back at this parabola I can see that crosses the y-axis at negative 2. The coordinates of this point are 0, negative 2. And the coordinates of any y-intercept, the x-coordinate will be 0 because it's on the y-axis. So you didn't go left or right at all to get to the y-intercept. You just go up or down. Okay? So that means to find the y-intercept, what I can do is plug in 0 for x. Okay, so in the original equation, and I'll use a y again, plugging in 0 for x, and then I'm going to solve this for y. So 0 squared is 0, 6 times 0 is 0, so that leaves me with just y equals 5. That is my y-intercept, okay? Now, you might notice when you start to do these that, you know, if you're plugging in zeros for the x squared and the x term, they'll always turn into zeros, and then you'll just be left with whatever's at the end, which is always the c, okay? So the c here, that is going to be my y-intercept when I'm in standard form like this, okay? So that's also just the c value. So if you know where to look, then you don't even have to do any work on this, okay? All right, let's try this next one. Now this one is a little strange because there is nothing added or subtracted to the end. So I'm just going to put in a plus 0, okay? So that means a is 3, b is going to be negative 2, the negative is part of that, and the c is 0, okay? So axis of symmetry, x equals negative b over 2a, okay? So let's see, the b is negative 2, that goes there, and then the a is 3. And let's simplify. The opposite of negative 2 is positive 2. 2 times 3 is 6. And we can reduce that to 1/3. But then I don't want to just write 1/3. I want to write x equals 1/3. So that it's the equation of a vertical line. Okay? Now I know the x coordinate of the vertex. That's 1/3. I don't know the y yet, but I can find it by plugging 1/3 into the equation for x. Okay? And there's two places where there's a 1/3. I don't need to write in the plus 0 because it doesn't do anything there, right? But let's do the exponent first. So let's square 1/3. Well, 1/3 times 1/3, you'd multiply straight across and it'd be 1/9. Or you can square the top and the bottom. Okay, and I'll do this multiplication. Negative 2 times 1/3 would be negative 2/3, because you can think of that as negative 2 over 1 times 1 over 3. Okay? This fraction here will be 3/9. So I've got 3/9 minus 2/3. And then I can reduce the 3/9. I'm going to have to work this way because I ran out of space. Okay, now I've already got a common denominator. That worked out nice. And then on top, I'm going to do 1 minus 2. That would be negative 1. So that means negative 1/3 is my y-coordinate. Okay? And then the y-coordinate is just going to be the c value, so that is going to be 0. Okay, and then let's talk about domain and range of these functions. So the domain is all possible x's, and the range is going to be all possible y's. Okay, so the key to the domain and range is the vertex. All right. So when you're looking at the x's for these parabolas that open up or down, this parabola is going to stretch left and right forever. So that means it would have any x is going to be on somewhere on this graph. So the domain is going to be all real numbers. Okay, and the same thing's going to happen, even though it kind of looks like it's flattening out, it's going to stretch left and right forever. So the domain here, again, is going to be all real numbers. For any of these parabolas that open up or down, the domain is unlimited. So we'll say all real numbers for that. Okay, now the range is limited. So the range, we're talking about the possible y's. Okay, so I'm thinking, well, here, this is the lowest point on the graph. So that is the smallest y I can have is negative 2. And it could be anything above that. All these other points have a y that's greater than negative 2. So the way I can express this, my y's are greater or equal to negative 2. It's negative 2 or anything bigger than that for the y's. Okay? All right, so on this one, when I'm looking at, hey, that's the highest point on the graph, so that means that this is my biggest y. So the y's can be 3 or anything less than that. So I'm going to say my y's are less than or equal to 3. Okay, there's my domain. Okay. Okay, so that idea is very related to minimum and maximums of values of parabolas. Okay, so if you have a parabola that's opening up like this, then it's going to have a minimum value. Okay, and we're only looking at the y's because the y's have to do with the height of these parabolas. So the minimum value of a parabola that opens upwards is going to be the y value of the vertex. And the maximum is going to be the highest point on a parabola opening down, so it'll be the y value of the vertex on both of those. Okay? All right, so let's find the minimum here. So I can see that this vertex is the point -3, 1, but I'm only looking at, that's my minimum height, and the height is only the y, so I'm going to say that y equals 1 is the minimum, okay? And then here, this is the point 24, and that's a maximum because it's the highest point, but I'm only interested in the height when I'm talking about a maximum, so I'm going to say my maximum is 4, okay? All right. All right, so let's look at another here. So we're going to graph this parabola. So this is standard form is what this form is called, ax squared plus bx plus c. So let's start with the axis of symmetry. X equals -b over 2a. So the b is 6, and the a would be 1 because it's a 1x squared, right? So I've got -6 over 2, which is -3. And then I want to write my answer as x equals -3. And I'm going to put these things into the graph as I go, okay? So x equals -3 is a vertical line right there. Okay, that's really helpful. That's the middle of my parabola. Also, I know the vertex is going to be somewhere on that line. So that means I know the x coordinate of the vertex already. I just need to find the y that goes with an x of -3. So in the original equation, I'm going to plug in -3 for x in both positions, and then I'll use PEMDAS to solve this for y. And I used y instead of f of x, but you could use f of x if you wanted. Okay, -3 squared is 9. 6 times -3 is -18. Okay, 9 minus 18 would be -9. And then -9 plus 5 is -4. So -3, -4 is the vertex. Let's go ahead and plot that. There is my vertex. I'll put a little V. I guess for my axis of symmetry, I should technically put the little arrows to show that goes on forever. Okay. All right, now let's find the y-intercept. So you can plug in 0 for x. That's totally fine. But this is going to be your y-intercept when you're in standard form, because if you plug in zeros, those two terms will just drop out, okay? So you could put the coordinates of that point, or you could just say the actual number of the y coordinate, but that means it's going to cross the y-axis right there, okay? All right, so I'm going to graph this parabola just from this information. I've got the vertex. I can see this is going to open upwards, which makes sense because the a value was positive. Okay, but what I can do with this point, this y-intercept, I can find another point because this should have a mirror image on the other side of the axis of symmetry. So I can see, hey, this is 3 units from the axis. So if I go 3 units out the other side, there is the mirror image of that point. And now I have enough information to make a really nice graph. And you could find more points by plugging in different x values, right? I could plug in -2 into the equation to get, or -1 or whatever to get more points. But here I've got enough to make a pretty decent graph. So you'd want the vertex at a minimum and at least 2 other points so that you can get the width of the parabola as well. Okay? Now finding the minimum or maximum. Well, this is going to have a minimum. So I can see my vertex is -3, -4. And the minimum is the height of the vertex. So that means my y value is going to be, my minimum is going to be -4. Okay, it's just the height of the vertex. Okay, and then domain and range. Well, domain for all these parabolas is going to be all real numbers because it stretches left and right forever. But then the y is based on the minimum or maximum. So if this is my minimum y value, then y's can be anything bigger than that or equal to it. So my y's can be greater or equal to -4. Okay, and then we've already done the graphing part there. Okay, let's try another. So, all right, let's find the axis of symmetry. X equals -b over 2a. So the b is -10, and the a is -5. Okay, so the opposite of -10 is +10. 2 times -5 is -10. And then when you do that division, we get -1. And it's x equals -1, not just -1. Okay, so x equals -1 is going to look like this. I like to use a dashed line for the axis of symmetry. There's the middle of my parabola. Okay, now let's find the vertex. Well, the vertex is somewhere on that line, so I know the x coordinate is -1. Just need to find the y coordinate. Okay, so that means I'm going to be plugging -1 in for x into the original equation. Okay, and then I'll use PEMDAS, so I'm going to do the exponent first here. Okay, and -10 times -1 is +10. So now I've got -5 plus 10 minus 2. Well, -5 plus 10 is +5, and 5 minus 2 is 3. So -1, 3 is my vertex. Okay, so that's my vertex. Okay. This parabola is going to open down. I know that because the a is negative. But let's see what happens when we find the y-intercept. The y-intercept is this. Because if you plug in 0 for the x's, those two terms will drop out. So my y-intercept is -2. Okay? So here's the y-axis. That's where my parabola crosses the y-axis. Which makes sense if I've got a parabola opening down. Okay? So now I'm going to use this point to get another point, because that should have a mirror image on the other side. So I can see, hey, that's 1 unit away, so I'll go 1 unit out the other side, and now I'm going to have a parabola like that. And it's pretty narrow, which makes sense because we'd have a vertical stretch of by a factor of 5 there. Okay. All right, so let's look at the minimum or maximum. So this one's going to have a maximum. I think I forgot to say that on the last one was a minimum, but this one has a maximum, and the maximum, I've got the, I want to use the y-coordinate of the vertex. So the vertex is -1, 3, and then so I want 3 for my maximum, okay? And then let's look at domain and range. Domain, this stretches left and right forever, all real numbers. And my range, I'm looking at the possible y values. So y can go up to the vertex, or it could be anything below that. So I'm looking at the height of the vertex, which is 3. So my y's can be 3 or anything less than that. That's my maximum y, right? So I can say y is less than or equal to 3. Okay. All right, on the last page, we're going to do an application, which means a word problem. Okay, so here we've got a bridge, and it says the cables between the two towers of a bridge form a parabola. So here's our parabola that can be modeled by this equation, where x and y are measured in feet. And we want to know what is the height of the cable above the water at its lowest point. So let's think about what they're asking for. So the lowest point on the parabola is going to be down there at the vertex, right? So it's going to have an x and a y coordinate, but then we're looking for the height. So the height would be related to the y coordinate. So what we're looking for here is the value of the y coordinate of the vertex. Okay. So in order to find the y coordinate, first we need to find the x coordinate. And we can do that using the axis of symmetry formula, which is x equals -b over 2a. Okay, so if you look at this problem, the a is going to be this decimal here. B is going to be -0.46, the negative is part of it, and then the c is the 507, okay? So in this formula, we want the opposite of the b, that's negative 0.46. And then we've got 2 times a, and a is 0.00016. Okay. All right, so simplifying this, let's see. The opposite of negative 0.46, that would be positive 0.46 on top. And if we double this decimal here, you can just think about doubling the 16 part. If you double 16, it's 32. So I'm going to have a decimal point and then 1, 2, 3 zeros and then 32. 1, 2, 3, 32. Okay? And then I'm going to put that in a calculator because I don't want to do that division by hand, but I've got 0.46 divided by 0.00032, and I've got this number, which is 1437.5. Okay, now that's the axis of symmetry. So that's the equation of the axis of symmetry. So that's really giving me the x coordinate then at the vertex. So my vertex here is going to be 1437.5 and then something for y. So we still need to figure out that something, okay? So our vertex is right there, right? So we've got the x coordinate. Now we still need to find the y coordinate, and the way that we can get the y is by taking the equation that we have and plugging in the x value in both those positions. So I'm going to plug in this 1437.5 number in both those positions. Okay, so I've got 0.00016, then I've got 1437.5, and that's squared. Okay, minus 0.46 times x, and x is this number again. Okay, and then we're going to add 507 to that. Okay, so this is a long equation, but we can just sort this out with a calculator. I'm not going to square this by hand and do this multiplication by hand. So let's start working on this. I got 1437.5 squared. So you could just multiply it by itself if you don't have a square button. And that gives me this number, okay? So I'm using PEMDAS here. I did the exponent first. Okay, and I'll multiply these together while I'm at it. So 0.46 times 1437.5 is that. And we're subtracting that, right? So it's going to be negative here because I got a negative times a positive. Okay, now I want to do this multiplication. 0.00016 times that number that begins with a 2. And I've got 330.625. Okay, and we're getting there. Okay, let's do that subtraction now. I still got that number here, so I'll just subtract 661.25 from that. And then last but not least, let me zoom out. I'm going to add 507 to this. And that gives me 176.375. Okay, so that's the y coordinate of the vertex. And now I can go back and put that in here, 176.375. And remember, they're asking for the height of the cable at the lowest point, the height above the water. So that would be this number. Okay, and these are in feet. They're measured in feet, so I want to say that many feet. So my final answer, I suppose you could round that, but I'm just giving the exact answer because we've got it right there. Okay, all right, that's the end of the section, and I'll see you next time.